so welcome everybody. We're a few minutes early, but we thought we'd, just get started and chat a bit. So thank you so much for coming. As the name says, I'm Don Murray. I'm one of the founders at SAFE, and awfully exciting topic. And I'm here with Stuart. Hey, Stuart.
Morning, everyone. Morning.
Yeah. And Stuart leads our cloud endeavors at SAFE. And and also looks after a lot of the connectors to cloud-based technology, and so I work on a day-to-day basis with Stuart. So this is an exciting topic for sure. And Steph, who keeps everything running and make sure our slides look good, and make sure that I remember to look good myself, well, as best as I possibly can. So yeah.
No, we also have Steve on the back end as well. He just turned off his camera, but we could force him to come back on. He's going to be running Q&A in the back. So if anyone has questions throughout the webinar, there's Steve. Please chat them in.
So I think with that we can. It's 8 o'clock, so we can start, and we'll turn off our cameras really quickly because we know bandwidth is an issue for some of you. And so I'm the only one with camera still, so I'm going to turn that off now.
I can prompt you to close it. Oh, there we go.
There we go. Okay, so we're going to talk about working with spatial data and at scale in the cloud with FME, obviously. So so good.
Yeah, so I mean, we could introduce ourselves again, I guess. As Don mentioned, I'm Stuart Harper, so I kind of run the cloud group at SAFE. I've been at SAFE and Canada now actually for nearly 11 years. It's been great fun. And I kind of run, there's two parts of it. One is the FME Cloud product, which is our platform as a service, and the other is look after kind of all of the cloud connectors connecting to AWS, Azure, Google Cloud, IBM.
And my name's Don Murray. I'm one of the founders. Still very much technically on the ball, and I work very closely with Stuart, and I work with the server team, and of course XML, and help drive the direction and the vision of SAFE with Stuart and Dale and many other folks at SAFE. And we get ideas internally. We also talk with customers and clients, and just follow the industry. So that's what I get to do, and it's just so much fun to get to work with such a great team of customers and SAFers and partners. And so happy to do this morning.
That's going to be good. So cloud databases, they've been around for a while. I was actually Googling last night, and it's over kind of 11-12 years since the first cloud databases came online. So they're relatively mature, but it's actually really only in the past few years now where the kind of spatial adoption across all of the cloud databases has really shot up. I think that just shows you how important spatial data has become in kind of the business making process. So we're gonna dive in and really look at what the spatial adoption currently looks like, because it's changed a lot in the last year.
Good. And our mission at SAFE is really simple. It's to help everybody maximize the value of data. More data is collected than ever before, all kinds of data. And our mission is to, wherever that data is, we want to enable you to get access to it or push data into it and connect all your data together so you can extract more value. Also connect the data to the applications that you're using, connect applications to applications so that you can reduce keystrokes. If something happens in one application, you want it just pushed to another one. And anything to deal with data is what we do. So you can think of us as the data pipe guys. We just connect data from wherever it is to wherever it needs to be. Good. So our what we offer is the FME Integration Platform, and we talk about this idea of connect, transform, and automate. And that's really when you're building your FME flows, that's exactly what you do. You first connect to both the source systems and the destination systems. There could be many sources, many destinations. And the connections at the lowest level when you're connecting data sources is done with our graphical interface, which is on FME desktop. And that's where you can build and run with these data flows. Once you've done that, you can, if you want to automate it, you can push it to the FME server, and this is where you can start to connect applications together, automate based on schedules or data arriving, and you're going to see some of that. And the power of our platform is really this notion of transforming, because often data in your source system or from one system isn't in the right structure or the right format or the right form. When you talk about spatial data, it could be in the wrong coordinate system. So, and that's something also that we can resolve. If for those who are not familiar with spatial, the world is round, maps are flat, and so there's a number of ways of resolving all those issues. And then we have our FME Cloud, which is our hosted FME solution, our FME server solution in the cloud. So just removes all the headache of infrastructure. You can scale it up, scale it down to meet your needs. And of course, we have mobile apps which also enable you to take the power of FME server on the road. So yeah, good. Yeah, and again, this is pretty much what I said. First, you connect to sources, and there's more and more sources. It says 400 plus there, but once we get into web services, really with FME, you can connect to thousands and thousands of web services. We make it really easy, using a no-code approach to connect to all these different sources, so that you can, connect various applications. So if you pick an application that's safe, we use many. We use Salesforce, we connect to that. We have Slack, we connect to that. We've connected, you name a system. If it has a REST API or a SOAP API, you can connect to it with FME. So, and transforming your data, again, getting it the way you need to see it. And it could just be bringing multiple data sets together to derive a new data set that each data set on itself does not have. And so you can do things like that. And automation, that's really what FME server is about. And again, both automations and the authoring of the data connections is all done graphically through really productive and easy to use web interfaces. Yeah. And here's the different types of data that we connect. And you notice that we're not saying this is spatial data. This is all kinds of data. So while FME, there's no tool like FME that can work with spatial data, and spatial data, as Stuart alluded to, is becoming more and more important, not just in the enterprise, but worldwide. So really that's safe strength, and nobody can touch us there. We continue to invest in there. But clearly there's all this other data that is not spatial, and we work with that too. So we have customers that are using FME for spatial solutions. We have other customers that are using us for traditional database or application solutions. And then we have customers that are using us for both. And more we're starting, as the spatial data becomes important, we're seeing organizations adopt FME, because it really is the only enterprise integration tool that can handle the spatial data.
Okay, so yeah, let's have a quick overview of the agenda. So we're going to briefly kind of talk about what cloud databases are currently available, and we kind of categorize them into 3 groups. And then we're going to go into some scenarios that kind of cover all of the databases we're going to talk about in the first half.
Awesome.
Yeah, so look, we've got a brief poll now, which should be coming up on your screen. We're just asking, are you currently leveraging a cloud database? Give you a few seconds here. Should be interesting. This has probably changed quite a bit in the past few years.
Oh yeah, I mean, it's really, the whole cloud space is really exciting, and to see, as we're going to see in this talk, the way that these different sort of types of cloud databases that are coming online, and we're kind of we're going to start from sort of the more traditional databases up to the more recent ones, or the ones that are built on top of cloud technology. So yeah, okay.
So I'm going to close this down in 3, 2, 1. Last votes in.
Huh. Yeah, there we go.
Awesome. Yeah. So 45% of the people are using them. So that's great. And then the rest are here to evaluating and just for the learning what the options in the future are. So thanks for coming and thanks for doing our poll. So
To share, thank you.
yeah.
Okay, so yeah, we kind of categorize the cloud databases into 3 groups that we're going to talk about today. Now, to be clear, I mean, this is a kind of, we've segmented things here, and some databases do kind of fall between these categories here.
Mm-hmm.
But generally, this is kind of a good way, and it's a way that the cloud platforms actually segment things as well in their marketing. So the first one we'll talk about are the cloud native relational databases. So, you know, relational databases have been around for decades, and I looked up last night when the first databases came onto the cloud platforms, and it was the relational databases. They were first, and they were in 2009. But what these cloud native databases are, to talk about more specifically, these are databases where the cloud vendors, so Google, AWS, Azure, they've taken a traditional database engine such as SQL Server, MySQL, and they've really optimized it and tuned it to the cloud. So to their cloud more specifically. So they've done things like integrated it with other services like machine learning services. They're transitioning these databases to be serverless. They've improved the performance. They've improved replicating the database globally. So really, they've really tuned these databases and they're really optimizing them to work on their cloud platforms. And that's really exciting because it's kind of taking this mature technology and really kind of modernizing it and bringing it up to speed. And the great thing is here, they all use standard database engines, as we'll see, and FME works with all of these just like on-premises deployments. So if you've got SQL Server or MySQL or PostGIS running on-prem and you can connect to them with FME, you can connect to all of these cloud native databases using the same readers or writers.
Yeah. Yeah. Good.
So typical use cases here, I mean, my guess is if we did a poll here, most of you out there would probably at some point in the past have had your spatial data in a relational database. They've been around for a long time. So, you know, if you're looking to port your existing on-premises applications up to the cloud and there's a database behind that, it's worth a look. You know, you should probably start with looking at these cloud native ones just because of the features they're now offering. But really, you should really start taking a look if you want a really high level of uptime. So, you know, that means you don't want any downtime, a couple of seconds a year maybe. Or if you're really struggling with performance on-prem, you know, you've got hundreds of millions of records, your queries are taking a long time. In some cases, these cloud native databases can be much more performant. So what this is we're showing that the main cloud native relational databases on each platform, AWS, Azure, and Google. And so you can see here, let's take a look at Aurora first. They support MySQL and Postgres, and both of these engines have the full spatial data types enabled. So, you know, this is really exciting because you've got PostGIS, you've got MySQL, all the spatial functions are there, all the supported types, and FME can read, write, and query this database. And you start to get lots of goodies with Aurora. Serverless, you know, very, very performant. They've been tuned. There's a whole bunch of things you can look up, but yeah, this is exciting way to kind of deploy this geospatial database. And then Azure, equally, they've taken SQL Server and they've done even exciting things as well. But again, it's the full SQL Server spatial that you can interact with here. They've got serverless options. You can integrate with their machine learning services directly. Again, you can use the FME reader and writer here. And Google Cloud Spanner, they don't actually have native geospatial support here, but they do have this Google S2 library, and it seems Google actually use this themselves on Google Maps. So I personally haven't used it, but I imagine it's you know, a solution worthy a look as well. So I think the key points here, you know, compared to a traditional relational database, you've got your PostGIS, you've got your MySQL or SQL Server. When might you be looking to use this instead of just kind of using a standard hosted relational database? Well, we've got performance, high throughput, and this global replication is a really hard thing to do. So if you have a global application, maybe a web application, and you want to have performance in Asia, North America, Europe, and quickly to kind of deploy your app globally, then these databases enable you to do that. Scaling is built in, so you know some are serverless, but if they're not serverless, then it's very, very easy to configure auto scaling of both the compute and storage. And the key thing here is, you know, it's so easy to port your applications up to the cloud. You're staying in the same database engine, so you don't have to change the schema or even the configuration, which is, yeah, it's really, really powerful. And yeah, you can leverage the strength of the cloud here. As you shift up to these cloud native databases, your management overhead drops even more compared to a normal database. Yes, I don't know if you've got anything to add there, Don, but
I was just gonna stress. I mean, what you said about just how easy it is to move your database to the cloud. I mean, I used to use FME Engine or my FME server with my own, you know, database on my system, and now I just have one running in you know, Amazon, and I just use it all the time. And whether I'm on-prem or in Amazon, my FME doesn't know the difference, and everything just works. So it really is, you know, amazing how well these things just work exactly like the one on-prem. So that's I think this is the easiest way to get your existing applications, you know, to the cloud.
Right. Yeah. And I think we'll see more and more innovation on these databases. You know,
Yeah.
I expect all of them to be kind of fully serverless within a few years, which will be a huge deal.
Yeah. And that's the other thing that Stuart just mentioned that's exciting is, you know, when you have stuff on-prem, it's, you know, it's the technology installed every day, it's going to be the same. But with these services, you know, all these cloud vendors are busy in the back improving the technology. So, you know, your database gets faster, and all these improvements happen just with just because it's, you know, it's a cloud service. So it's that's another benefit. Yeah.
Yeah, and it's not like, you know, if MySQL releases a new release on the kind of open source branch, then it's not 3 years later that it appears here. It's very, very quick.
Yeah.
You know, so
Yeah.
it's not a problem on that side either. Okay,
Yeah.
so that's proprietary cloud relational databases. Do you want to introduce this one, Don?
Sure. So NoSQL databases are basically for unstructured data. So often you might have, you know, maybe you have job logs that are being streamed in, or you have applications, let's say mobile applications where data is coming in. Typically the data can be in JSON, but it could just be wrapped and stored. And you know, and these just allow you to store data, you know, at a crazy rate, and also be able to query it. And yeah, and again, you're going to hear the word serverless over and over and over, which is the way the cloud in general is going. I said, you know, if we're looking at a trend, that would be it. Yeah. So here's some typical use cases. So, you know, a mobile application where you're collecting user locations across the globe, and you want somewhere to store stuff very, very quickly. You know, a point of interest store there that, you know, billions and billions of points, and you want to give really fast queries into that point database to retrieve the you know, the data. Sensor data with 5G and other things, you know, there's sensor networks are being written, and often you want to just store the data really, really quickly. If there's one thing that we're seeing is we're in this world now where we store everything, no matter where it is, and being able to store raw data, you know, from a sensor network where the schemas might change as it's updated, or maybe you have different sensor networks that the schema is not the same, and you just want to pound it into a database, and that's where these are great. And the last one's there's nothing spatial about it, but in large enterprise organizations, often they store, you know, everything that happens on a system somewhere. and a NoSQL database is a great place to put it for auditing or playing back or things like that. Yeah.
And this the thing with all of these scenarios, like if you're in, say, Pokemon Go and you want to request some kind of query, you don't want to be waiting seconds, and there might be billions of records. And if you've got a lot of records here and you want really, really low latency, this is pretty much the main solution you need to be looking at, NoSQL. And the nice thing is you don't have to do anything. You just put your data in there, you index it, and then the cloud provider handles kind of all of the underneath infrastructure for you.
Yeah.
Yeah, so there is slightly less spatial support in these databases, right?
Yeah.
And you had a play around with DynamoDB many years ago.
Yeah, I played around with that QHash thing. There was a blog I wrote many years ago where I was playing with it to do some spatial stuff in it. It's the library is now been archived, but we have users using DynamoDB for spatial and non-spatial. So I guess this says that really in this case its strength is more for the non-spatial area for sure. So yeah. And then for the other two, we have like Cosmos DB supports two types. It supports geography, which is long coordinates, and geometry, which is XY. So different ways of storing the data. And so this is where FME's coordinate reprojection capabilities are really key, because you can't just put data into a database in the wrong coordinate system and expect good things to happen. And but again, with FME, we easily do that. And the nice thing about FME with all these databases we're talking about is we hide a lot of the details, so you can focus on just getting the data in or getting it out, while yet giving you access to the underlying power of the databases. So yeah, that's our stick. Yeah.
And you'll notice here the spatial functions, PostGIS maybe has, 100 spatial functions. And you might be thinking, oh, well, there's only 3 spatial functions here. But if you think about this, if you have 2 billion points in a table, and you can do a within spatial function against those 2 billion points, and it returns within 20 milliseconds, that's a definite use case.
Yeah, absolutely.
It's impressive.
Yeah, so for these ones, they have fewer, but the ones that Stuart mentions, the ones they have there are super performant and
yeah.
And
And the other thing is you can always store like GeoJSON and WKT in the table, so you could store them as just like a string, right? And you can't query against it, but you could still pull them into FME and turn them into geometry to do queries.
Yeah.
Okay. So I think we've kind of gone over all of these.
Yeah.
The last one's interesting. Yeah, you don't provision a server on these. You don't pay for the server, and Cosmos DB just went serverless last week. Actually, you pay for capacity or the work done. So this is,
and that's another trend really we're seeing is you of course you pay for the work done, and you pay for your storage and your network traffic, but often that is just at the cost of the cloud anyway. And which is really, but just paying for the work done, that's really a new trend we're seeing. You no longer even think about servers, which is really exciting.
So ask yourself these questions. Do you have unstructured data you want to be able to store and query? Do you have to store data that is not consistent or evolving quickly? Or do you need to store logs or other activity? Then, NoSQL could be the answer for you.
Yeah, absolutely. So good.
Okay, so let's shift now over to one of the most kind of emergent categories.
Yeah, and these are the ones that have been built from the ground up to exploit strengths of cloud technology. So these ones, the vendors, they saw all the things cloud could do, all the services available, and then they built databases on top of these that just leverage the strength of of the cloud. So you'll never see these. I should never say never. You won't you won't see these on-prem. So you're not gonna. But you know, so that's really exciting. Yeah. Yeah.
Okay.
You want to talk about the rest, or?
Yeah, I can do. Yes, I mean that these databases are typically for, you know, you load vast amounts of data into them, and then you ask questions of the data. You know, run queries against the data. So it's really for, you wouldn't really use these. You wouldn't sit a web application on top of these. You'd use a relational database for that on NoSQL. These are more for doing like business analytics, and yeah, you'll see in a second that some powerful scenarios.
Yeah. Yeah. Yeah, so some of the use cases, I mean, you know, if you, it's, you know, I always ask myself, if I was starting a new application or building, you know, or I knew I was going to port an application to a new underlying data structure, this is one that I would definitely consider. You know, you know, the nice thing is if your application really grew huge, you know, you're going to be covered, and often, you know, you have to do the cost analysis, but often these are really also, you know, pay for what you use. And so, and this is Stuart alluded to, that these are not three separate bubbles. If you drew a Venn diagram, you would have the typical where you would have some operations or could be done by any of the three. So, and that's where, you know, as you're building an application, you would have to really yourself decide. The nice thing is no matter what you decide, or if you change your mind later, FME is there to be able to help you. And your application might need both. You might, you know, as some of those show there, you know, you might have just a, you know, gargantuan amount of data in a NoSQL database, but then you want to like pull it out into a data warehouse to do more different types of work. So you know, so you can see that load subsets of data from NoSQL into these for further analysis. You know, subsets of data might be here. Maybe data that's, you know, within the last 2 years is in one of these, but then when it gets older, you push it into NoSQL. There's so many different ways you can work with all these database solutions. And really, another point we want to make is that your solution doesn't have to just pick one. And you know, it could be that it's most cost effective to pick several. You know, like we store all our data at Safe and S3, but then when it gets really old, we push it to Glacier because we know we still have it. And it's you know, cost is always a factor in when you're building your you know, your solution. So yeah, but these ones are exciting, no question.
Yeah, and the last one, I'll just explain the last one a little bit because it's probably not that clear. Number 5. So what they're all adding now, Snowflake just added, you can do it in the AWS one as well. Say you have loads of just JSON files or CSV files in like cloud storage, like on S3 or Azure storage, you can actually now index those files, leave them where they are, index them with these data warehouses, and then you can run the querying through the SQL interface in the data warehouse. So that's crazy powerful because you don't need to load all of this data into the database. And you can do geospatial queries as well against those data lake stores.
Yeah, it's very amazing.
Okay, so again, yeah, an overview here. So I mean, we've added Snowflake as well on here because it's, you know, an amazing database, and they have great spatial support as well. But I mean, the main thing I want to pick out here is just the spatial types are different, right? So Snowflake and BigQuery, they support geography, so degrees, Earth is round, and then Redshift is geometry. And we'll see that later on in the scenarios.
Yeah. And you know, obviously AWS is on Amazon, Azure's on Azure, and Google's on Google. Snowflake is interesting. It's on all of them. So again, you can, you know, pick and choose. If so that with that one, if your solution's on Google, you can use Snowflake. If it's on Azure, you can pick Snowflake. If it's on AWS, you can pick Snowflake. And like the other ones, built from the ground up, leveraging all the underlying services that are available in the cloud to, you know, build, you know, all of these are amazing, the performance that you get. So yeah.
Yeah, and we've been playing around a lot with all of them. An example we had, I think I had about about 3 billion records in Google BigQuery, and whatever query I threw at it, I couldn't get the query to take longer than 15 seconds to return.
Yeah,
Which is,
yeah.
I mean, you tried optimizing a relational database to do that. It's, yeah.
I know. And the management of these is so easy too. It's not like the old days where you had to really, really, think about your indexes and things like that. Many of these just take that all away. And the fact that all of the big, you got AWS, you got Google, and you have Snowflake that all have spatial, just again reiterates how important spatial data is becoming. And
exactly.
If you choose a solution to work with these systems that doesn't have spatial, then you may find you're going to need to address that later.
Cool. So let me just, yes, I mean, again, I think we've kind of covered all of these. That the main thing here, that one interesting point. So I bet your GIS team all know how to use SQL. And that's the thing with these, you just need to know SQL, that's it. There's no real kind of ramp up in knowledge required other than that, which is really great.
Yeah. And with FME, even if you don't know SQL, you can get amazingly far. We have these joiners that enable you to build these queries graphically, which can really help for simple joins or simple queries. Our philosophy with FME is always push. We always make it easy to push all the work you can to the database. And then FME just works with the residuals of those queries and does and takes it the final mile or whatever you want to talk about when you're bringing databases together. So for all these solutions, it's not the case we read all the data and then do things with it. We always, push the work to the database where it belongs. And so, all these have amazing SQL interfaces where you can write, super complex SQL that goes on for pages and pages. And with FME, you can simply put that right in an FME, the SQL executor, and away you go. So it's great. Yeah. Yeah. So for these ones, I mean, if I was building a new cloud-based solution, I would I knew it was cloud specific. I would definitely, take a look at this technology. This could be definitely be a strong contender. Yeah, large volumes, and you want a SQL interface, as Stuart said. We're all familiar with SQL, and yeah. And the last one is if you're replacing the existing data, you're gonna re-architect your solution to replace an existing database for some reason with a cloud optimized one, then again, take a look at these ones. The key is if you have a SQL interface, you want a SQL interface, and and you have schema that's relatively predictable, then I think these are definitely worth taking a look at.
Yeah, and you don't get as many queries, you don't get as many spatial functions as like SQL Server or PostGIS, but you get a lot. It's powerful.
Yeah, it is. And again, all these, this is kind of interesting webinar. It'd be interesting to do it again in a year because this whole area is moving so quickly. A year ago, we wouldn't have even, there would have been some of the vendors that weren't here. They wouldn't have all had spatial. It would have, so it's pretty exciting times.
Yeah, Redshift and Snowflake have added spatial in the last 6 months, I think 9 months. So
yeah.
And BigQuery maybe as well in the last year. Yeah,
absolutely. So. Okay, so poll question. What cloud platform are you currently using?
Or not.
Right.
So I'll just leave this open for a few seconds here while people get their votes in. I'll mention as well, for anyone joining us late, we have Steve running Q&A. So if you have any questions or comments about this webinar, please type them in the chat panel. We're running it throughout the webinar, and we'll also do Q&A at the end. And we are recording this webinar as well and are going to send out a link to the slides and recording afterwards. And I think with that, I'm going to close this down. last votes I see coming in. Okay, I'm closing it.
Okay. Yep. Wow. There we go. Interesting. Yeah.
So Amazon do have the bigger market share, but a lot of that market share is in kind of startups and smaller companies. So that's interesting. And I know a lot of conversations that we have, people mention Azure, don't they? So definitely catching up. Okay. Yeah, change of pace now then. So we've kind of given you a brief whirlwind tour of what's out there. And now we're just going to step through a few scenarios here and kind of show you how easy it is to kind of push and pull data from these various databases with FME.
Yeah.
So here in this scenario, imagine we're using Redshift, so a data warehouse, and we want to load data from multiple sources into Redshift. Actually, we're not just using Redshift, we're going to show you Snowflake and Google BigQuery as well.
Right.
I'm going to just minimize this and bring up the workspace here. So this is the workspace here. Let me just zoom in a little bit, get as big as possible there for you guys. So what we've got here is we've got a relational database here. I think it's actually a PostGIS database. And what we've done here is simulated rush hour in Vancouver. So we've simulated rush hour in Vancouver. There's about 3 million points here that we've got in this table. And what we want to do is join the simulation to fuel economy data, because we're going to load into these data warehouses to do some analysis on, how the fuel economy varies over the journey. So it's as simple as adding a reader here. And then what we're doing is we're joining, you see here, we've got the vehicle type, Nissan Altima, Ford Fusion. We're going to join that to the fuel economy data here, which has somewhere has the vehicle type in as well. Here we go, make and model. Unfortunately, not any Alfa Romeos, but you get the idea. And this feature merger joins the data together. So it merges the fuel economy data onto the relational database data. Now here's the interesting part, and that when we already mentioned this, we've got Redshift here, we've got Snowflake here, and we've got BigQuery here. So Redshift wants the data in geometry, so flat Earth, meters. So here we're using the reprojector to reproject to the NAD83 grid. So we can go in here and look at select coordinate system. And these are all the coordinate systems. How many have we got in here? There must be hundreds,
there's like
right?
tens of thousands of them, yeah.
Right.
And if you have one that's not in there, we have a nice little text editor and you can create your own. So there are some that are, organization specific, for example. Yeah. So
nice.
Yeah.
And then the bottom one here is we're reprojecting here to spherical Earth, so degrees. So again, we come in here and we just reproject kind of lat long.
Yeah.
And then we're going to write that out. So you can see how easy it is here to kind of reproject and massage the data and prepare it for these data warehouses here. And then you can just run this and load the data in. So
and again, showing how easy it is to write to different read from multiple sources and write to multiple sources. And really, the beauty of FME is if you wanted to go from one to the other, or maybe two of those three, decide you're doing evaluations or whatever, you can load all three, do some testing, and FME just makes it all easy. You don't have to know the specifics of any of the databases. It's perfect. Yeah.
That's a good point. And another thing I forgot to mention was, this file here is actually just on my local disk and kind of cheating a bit, but that could be on Amazon S3, Azure Storage, Google Storage, Box, any location really. We can pull and connect to any web service to get the data.
Yeah, and so sometimes we'll, like the city of Vancouver, for example, has its data on an FTP site. You can actually type FTP : and the name of the URL, and FME at runtime will just pull it from there. So yeah. So HTTP, FTP, it'll just grab it as if it's a file. Yeah.
Okay, so the next scenario, I think this is my favorite one actually. So this is querying data warehouses from within FME. So we wrote to data warehouses and read from Relational in the first one. This one, we're going to query a data warehouse, and then we're going to write to a NoSQL database. So the key thing here is we really want to leverage the cloud database to do the work, to do the query, and I'll show you why in a second. So I have an example here, and we've got it's a two-part of this. I have some boundary data here, and what I want to do here is we've got our 3 million points in the database simulating rush hour, but I'm just doing a study on Stanley Park and downtown Vancouver. So I just want to select the data right in the CBD of Vancouver. I'm not bothered about all of the rest. So there's two ways we can do this. The first way is the inefficient way, and I'll show you that one first. And what we're going to do is we're going to go out to Google BigQuery to get the data. So here we can see in here, the request to Google BigQuery is basically select star from this table, and I'm just going to filter by a few attributes. So I just want the medium and light vehicles. I'm not interested in the garbage trucks and the heavy vehicles. So I'm not going to actually run this in FME. I can show you what it looks like in Google though, and we'll see how many records it returns. So this takes, you see it took a couple of milliseconds to run, and it's returned 2 million features, 2.3 million features. And this is what it looks like, light SUV. So what we're then going to do in FME, I can show you what it looks like. We go out to BigQuery, we get the data, and here we're doing a spatial filter. So we're doing the spatial work in FME. We're reading all 2 million features in, and then we're basically passing in this boundary here for the center of Vancouver, and we're filtering based on that. So you can see it's reading all the data. It's got to read that through, apply it to the filter, and then we write out to NoSQL. So this does work. And this was kind of the way you would do it, I think, before the database had spatial support. Right. But let's stop that because it's inefficient, right? Yeah. What we want to do is leverage the cloud database to do the spatial query. So in this one, we're going to take these polygons here, we're going to dissolve them, we're going to convert them into WKT, which is just a kind of a text representation of the polygon. And then we're going to use that in the BigQuery request. Yeah. So I'll say that here. So you see the ST contains we've added now. So what that does is I can run this in here, and while it's running, rather than now returning 2.3 million points, it's just going to return the points inside here. And let me just, I think it's a bit clearer if I show you what the query looks like. So this is the query, this is the SQL that FME's generated. And this is a WKT here. And if I come in here and paste this in Google BigQuery and run it, you can see again, it's already executed, and it only returns 1,800 points, right?
Yeah.
And if I go in here, you can see it's reading the points, and it will actually be done in a few seconds.
Yeah. And that's a good example of pushing the work to the database rather than pulling it into FME to do it, for sure. Yeah.
And Don already mentioned we can do this with any database. It doesn't have to be a cloud one. We have a SQL executor, so you could do this with any of the cloud databases or any on-prem database as well.
Yeah.
Okay.
Yeah.
So nearly done. We don't need to wait for that.
That's awesome.
Okay. So let's hop over to a last one there, Don.
Yeah, so in this scenario, the idea is, okay, I'm writing data to, I'm using FME to write data, but the amount of data that I want to write is huge. And so how do I actually scale using, with FME so that I can do a big data lift, and things like that. So in this one, what we're going to do is we're going to read data from an IoT stream and load the data into the Azure Cosmos DB. But the data is coming so fast that one particular engine on FME isn't enough to to basically load it into the Azure Cosmos DB. So what we're going to do is we're going to use automations to easily to parallelize it. So do you want to open that? Go there, Stuart, and we can show.
Are we going to workspace first?
Yeah, let's go to the automation first. Yeah,
gotcha.
And then we'll show. Yeah. So the automation is really, really simple. I have 2 workspaces. The first one, all it does is, if Stuart double clicks on it, is it simply specifies the number of jobs. Oh, you can stop it, and then we can. Yeah. It simply specifies the number of jobs that I want to use. So this is where, if I had, depending on how many engines, I could parallelize it as much as I need to. And in this case, we picked 5, we could do 10, and then when we run it, it would fire up 10 of streams would come out. So the next job down that says many run in parallel would be based on what I picked. So that first workspace is really simple. It just outputs that number of messages downstream, specifies the number of streams that I'm going to be running in parallel, and that's it. And the second one, as well, the workspace is really simple too. So we can let's look at the parallelized workspace so people can just see how completely simple this is.
Okay, let's bring that up.
Yeah, so the first one is, it's called parallelize. Okay, yeah, that one will work. This is the one that loads it in. So you can see I kind of have a 10 transformer rule for my demos. And this one's really simple, connects to Kafka, and then simply just sets the coordinate system and then blasts it downstream. And the parallelized one is super simple too. So do you have that one there?
Yeah. Which one is this one?
It's called parallelize. Maybe you haven't loaded it. Maybe you have to do it. Oh, let's just go on back to the web interface. And oh, there it is. Okay.
Yeah.
And you can see this one's really simple. I just created an FME server automation writer that has stream, and there's a parameter that says how many streams do you want. And the creator, simply, if you open the creator, you'll see that it has a parameter, which is a number to create is the number of parallel streams, and that's it. And then I'm able to easily, parallelize the workflow to fire up many engines. And where those engines are in an FME server configuration depends on what's going on. It could be that it's the engine itself that has reached capacity due to CPU usage, but the machine it's on has more bandwidth left. So then you could launch another engine on that machine until you become IO bound. And once you're IO bound, now you need another machine. But FME server can be deployed across in a cluster. So then you could spin up other engines, on other instances in the cluster to get more IO to the database. And the beauty is that in automations and in workspaces, you don't have to worry about that. That's completely hidden by the configuration of the server. So yeah. So when Stuart runs this one now, we should see, we'll see 5 jobs running in parallel if he goes to jobs. Yeah, running. Okay, running there. Yeah, and you'll see there they are. They're all running in parallel. All reading data and and then pounding it into the data store. So yeah, so that's that scenario, and you can see the data going in here. And the question is, like with FME, the way we sell it traditionally is the number of engines. So if you needed 10 engines, you'd buy 10 engines. If you need 100 engines, you need 100 engines. But what if you need, what if you're doing a massive data load and you need 1,000 engines? Well, 1,000 engines, if you're buying 1,000 engines, that would be, the cost would be prohibitive. And so what we've introduced with FME 2020, so if you get FME 2020.1, now we have this notion of dynamic engines. And when we talk about serverless, then you don't worry about the size of the engines. When you buy dynamic engines, we could use the term engineless because you're not buying engines, you're buying engine time. And we have some clients who are using this. They're using spot instances. They're spinning up huge numbers of engines, grinding a lot of data. They're only paying for the work that is used. So, this is also in line with what we're seeing with, some of these databases like Snowflake and on the data warehouse side and the others. Now we're moving into the serverless world where you're paying for the work that's actually done. You're no longer paying for the capacity. So, you know, for these big data lifts or workloads that are really peaky, check out Dynamic Engines. It's sold by the hour, but billed by the CPU second. So yeah, and when your engines, if you have an engine there and it's not doing any work, you're not paying for it. So that's pretty exciting. Yeah. Yeah. So this is my favorite scenario. But as you might be able to tell.
It fits the IoT sensor scenario very nicely, doesn't it? Because most sensors probably aren't reporting constantly 24/7.
Yeah. Or you might have busy periods, like if you had a car counter in a shopping mall that was counting cars going in and out of a facility, there definitely would be peaky times and then quiet times. Yeah. So yeah. So there we go. So that's the three types of database warehouses and how FME supports them. Yeah.
Yeah, I think we can leave it at that, really, can't we? And maybe flip on to some of the resources. And then, do we do questions now, Steph, or are we going to go on to the resources now?
I mean, usually we do it towards the end, but you guys are welcome to do it whenever. Maybe just carry through the summary, and then at the end, when you guys are on the wrap-up slide, we'll take some time for Q&A.
Sounds good.
Sounds good.
Yes, so I mean, kind of covered this as well, haven't we? But yeah, as you said, Don, we have talked about spatial a lot today, but you know, we're well versed
any
in
kind of
spatial.
data, yeah, that's right. Yeah, if you have lots of spatial data, your decision's really easy. It's FME. I mean, there is no really other choice. If you're not using any spatial data, then you do have other options, but you need to be aware that at some point you may want to use spatial, and then you'll really need FME. That's what we do. So yeah. Good. Yeah, and our deployment options are, you know, we're not going to go a lot, but this just shows you basically not only do we connect to any type of data, you can run it anywhere, right? And you know, Windows 32, 64, Mac OS, Linux, Docker, and then Kubernetes, which is exciting. We're not, you know, that's a whole other discussion of, you know, of deployment, cloud, on-prem. We have some large customers running FME server on Kubernetes in the cloud and on-prem, and yeah, so that's wherever you want to run it, it's your choice. Is really the sort of like Burger King, I guess. Have it your way. Stuart's from the UK, so he has no idea what I'm talking about. And the other thing that's really exciting is, you know, we talk about this FME platform. Now you can license the entire FME platform and run it. It's ready to go on Google Cloud. And on Microsoft Azure, we also have the FME platform, which is the desktop and the server. Right now, it's bring your own license, but you can expect that to change. Or an additional licensing approach is more correct. And then coming soon, I'm going to say next week, or you know, the week after, is this multi-VM Windows Microsoft Azure deployment of FME server in the cloud. So you can basically go there, specify the number of VMs you want, hit a button, they're all spun up, and that's really exciting too. Yeah. So we have all three major cloud solutions. FME Cloud itself is on AWS, and these two are, you know, on the other two major cloud platforms. Yeah. Yeah, so there we go. So again, the point here is with FME is not going to dictate which cloud database solution you use. Our goal is to support all of them so that you can maximize, and your solution then is, your decision then is based on the database that best suits your needs and has the capabilities and the power that you need. Just knowing that FME can connect to it and make it easy to work with. So yeah.
Look at this guy, he looks pretty relaxed, doesn't he?
He does. Yeah, he does. He looks really relaxed. Yeah. That's not me though, because he has hair. So there you go. So yeah. So if you want to get started, I mean, one approach is you can download desktop and server, or you can go to FME Cloud. It's a great way to get started with FME server. We give you a free $250 credit, and that can, you know, for proof of concept pilots, that can take you a long way. And then we also have the cloud marketplaces, Azure and Google, that we can go. And of course, we've had people install download FME desktop and server and put them in any cloud they want. You know, we know it also runs in DigitalOcean, it runs in IBM Cloud, runs in Oracle Cloud, runs in, you pick your cloud. We basically have had success with, at one point we did a big test of all these Alibaba, of all these different clouds to see if FME desktop and server installed there would work, and it does. So there you go. We have a free 60-day trial of both. So we're happy to support you any way we can.
Nice.
Lots of licensing options. So subscription is where we're seeing a tremendous growth, and this is you know, a great way to grow your deployment. You don't have the initial purchase price, you just have a yearly subscription. You can grow over the year, adding more and more capabilities, switch things in and out over the year of your subscription, and then you renew. Individual licenses are perpetual, so you would buy and then you would have, you know, an annual maintenance for all the updates. And we have many organizations using that. And cloud deployment growing very quickly, as you know, which makes sense because we're seeing more and more, you know, data moving to the cloud, and that's where it's stored. FME, like any tool, likes to be close to the data. So yeah, and lots of different options there, from FME Cloud to these new marketplaces. So yeah. Yeah, good. And Dynamic Engine talked about it, but the point I want to make there is that it applies to, you know, it doesn't matter where FME is deployed. It works everywhere. It doesn't yet work with FME Cloud, but everywhere else it does work. So yeah. And lots of resources. So yeah. So. Good. And do reach out to us. One resource that if you go to safe.com, you'll see the chat window there, and you're talking with real people, and we really enjoy engaging with existing customers who are just starting out or just learning prospects, and if the person you're talking to, FME is such a broad product. If the person you're talking to is not the expert in your area, they just pull in the expert from, you know, and get you in touch with. So great place to go. You're starting out with something. Hey, maybe you're doing a new solution, and we see all sorts of different things. So really, we really won't like it when people engage with us and tell us, you know, what they're up to and how we can help. Yeah.
Okay.
I think we can do some Q&A now.
Yeah. So
let's have a look.
So lots of, yeah, so there was a couple questions around, you know, the data transmission, you know, between FME and the database. And in general, the answer is yes. If HTTPS is a way, is if it's a web service, that's just how the transmission is done. In some cases, we're using a client library from the vendor itself. And then, of course, the transmission across the wire is not going to be, you know, plain text or anything that anybody's going to be able to sniff. Security is something that when we talk about FME server and FME cloud, we take very seriously. We have an audit, but an external third-party audit done every year, and they, you know, sniff what's going on, you know, between FME server and the outgoing and incoming data, but also even within our components internally to you know, ensure that FME server is ready for the enterprise and is secure, and things like that. And security is one of those things that's a never-ending quest. You know, every year we make it more and more secure. Yeah, so hopefully that helps. Is Oracle an option in the cloud? Somebody asked. Yes, we support Oracle Autonomous, and that's, yeah, that could have been on our slide deck. There's just so many that we, and also we do have clients who are running FME and FME server in the Oracle Cloud. They would just install it themselves. So that's good to know there. Yes, do you see any questions there, Stuart? That
someone's asking, I see Azure Event Grid is supported, but what about Azure Event Hub? We're working on Azure Event Hub now, so expect that in the next 8 to 10 weeks, probably.
Okay.
And there was a question,
is Dynamic Engine exclusive to FME Cloud? No. It's basically for any version of FME. We have many clients running it on-prem, and so yeah, so nothing there. Yeah.
Yeah. Can you guys speak to? There was a question related to, does the SQL creator or executor work with all these different database formats you were talking about today?
Yeah, and the answer is there's always a way to run the SQL. So the vast majority, you can use the SQL executor to just paste in huge streams of SQL. So if Stuart clicks on the format, more formats, you can see them all there. And for some, there would be a specific connector that you would be able to paste the SQL in. But our whole stick is pushing as much to the database as possible. So if there's a way to take a query and get it to the database, that's what we want to do, because we recognize that many vendors have SQL or query language wizards, and they might type it in some tool, build a nice query, and we strive to and if there is, you find one that isn't, let us know, because I think all of them, there's a way to paste the SQL in there and push it to the database. And we don't interpret the SQL. You're allowed to replace values. So whatever the query language is, if it's in the executor, we just pass it straight through with the replacements done as indicated in the workflow to the underlying engine and let it do its magic.
Very good. And there was a question related to improving the NoSQL databases, supporting those NoSQL databases, and we're always looking to improve. So if you've got ideas or questions or anything related to improving formats that we support or don't support, don't hesitate to get in touch with us.
Absolutely, and you can do that through the chat. Even say, hey, I want you to improve support for MongoDB, for example, or whatever. Yeah. Happy to. Yeah.
Cool.
Good. Well, that's great. So thank you. We're right out of time on time. So so thanks, Stuart.
Yeah, thanks, Don. That was fun.
Yeah, and thanks, Steve and Steph, for pulling this all together. It's been a ton of fun, a hugely exciting area, and one that's growing. So with everything with FME, if there's something you would like us to do, really let us know, because that's another way we drive the product, is feedback from users to know what is important to them and what we're missing. FME is definitely a work in progress. We have a huge team of developers that's continually pushing the envelope, adding new stuff, extending our reach, and we love to get feedback on what people think we should do next. So yeah.
Awesome.
Great.
Well, thank you guys so much. I will close this down and take control back, but I'll leave it running for like another 5 minutes if anyone has a last question they want to get in. And then, as Don mentioned earlier, we have the live chat at safe.com that you can talk to us there as well. Or if you have ideas, I just chatted out a link to the FME community and you can post them there.
Thank you.
Well,
great. Thank you.
guys.
Yep.